want to start with number 4. Now, number 4 has a lot of parts, but it's not hard at all. So let's see if we can do this. Okay, so number 4, you will see one like this on the test. Here's my cliff. It's going to do something like that. And this value is given to me as 18 meters per second. And my angle theta is 40 degrees. And this is my dx. And this is my dy, 5.2 meters. And they want to know a bunch of things. First thing I want to do is get rid of that 18. So I'm going to say that the cosine of 40 degrees times 18 meters per second is my Vx. And when I did that, I got Vx to equal a lovely number, 13.79 meters per second. And then Vyi is going to be the sine of 40 degrees times 18. So Vyi is going to be, I got 11.57. Okay, part A asks you how long does it rise for, meaning the time. So I should know that if it's going to rise, gravity's going to have to stop it before it can fall back to Earth. So Vyf equals Vyi plus Gt. 0 is what it's going to get to at the highest point. Vyi is 11.57. Gravity on the way up is a negative 9.8 T. So when I solve for T, I got 1.18 seconds of rising time. Okay, B said, how high does the burrito rise above? So now I want to find that distance that it traveled during that 1.18 seconds. So I'm going to say, I'm going to do Vyf squared equals Vyi squared plus 2g dy. Vyf at the highest is 0. Vyi is 11.57. Gravity is a negative 9.8. dy is what I'm trying to find, and when I did that, I got dy to be equal to 6.83 meters. Okay, part C says, how long does the burrito fall? Well, I'm going to find out how far it falls, and then I'll know how long. I can calculate how long it falls. Well, it has to fall to 6.83 meters to get back to its starting point, and then 5.2 meters to get back to the Earth ground. So that's going to be 12.03 meters. If I did my math correctly, which I hope I did. Yeah, good enough. Okay. And so now I want to find that time that it takes to fall down to 12.03 meters. So dy equals 1/2 gt squared plus Vyit. Vyit is 0 because there is no Vyi at the highest point. Gravity has to pull it back down. So 12.03 meters is equal to 1/2. Gravity on the way down is a positive 9.8. So T is going to be 1.56 seconds. So that's how long it falls for. All right, and then D, how far does the burrito fall? Well, we already calculated that. So this is really answer D right here. And notice every number has a unit. All right, E says what is Vx? Vx never changes. So since we calculated Vx initially to be 13.79, it will stay the same because there's no gravity on the horizontal. F says what is Vyf when the burrito reaches the ground? Well, Vyf squared is equal to Vyi squared plus 2g dy. That's going to go to 0. So that's going to be 2 times a positive 9.8. And it's got to fall 12.03 meters. So I got Vyf to be equal to let me find it, 15.35 meters per second. And then G said, what is the resultant velocity, magnitude, and direction when it reaches the ground? So don't tell me it's 0 because it has a speed when it hits the ground. This is my 15.35. This is my 13.79. So doing Pythagorean theorem, I'm going to get B. B is going to be the square root of 15.35 meters per second squared plus 13.79 meters per second squared. So when I did that, I got B to be 20.63. And now I need the angle with the ground. So the tangent of theta is 15.35 meters per second over 13.79 meters per second. And when I got theta to be 48.06 degrees with the ground. So that took a long time, but it wasn't very hard. You will see one like that on the test. Okay, number 5 says no elevator. Fires a gun horizontally and the bullet leaves at 306 kilometers per hour. So that's a horizontal velocity, or Vx. The distance it has to fall is 3.4 meters. So part A wants to know how long is the bullet in the air, and then part B wants to know what is the final vertical velocity and then what is the range. I have to do a little work. Okay, first thing I want to do is convert that 306 kilometers per hour into meters per second. I got 85. The reason I want it in meters per second is because gravity is in meters per second squared, and it'll work a lot better. So I'm going to find the time. So dy equals 1/2 gt squared plus vy/it. Vyi is 0. So 3.4 meters is equal to 1/2. Gravity is 9.8. So t is going to be 0.83 seconds. That was A. And then B says what is the final vertical velocity? So Vyf equals Vyi plus gt. There is no Vyi. Gravity is 9.8 meters per second squared. And t is 0.83 seconds. So Vyf is equal to 8.16 meters per second. And then C wants to know the range. Well, dx equals dxt. So 85 meters per second for 0.83 seconds, giving me a range of 70.55 meters. Number 5. Number 6 says, a rows of corn throws a banana at an angle of 40 degrees with the horizontal. 40 degrees with the horizontal, sorry. The banana is going to rise 40 meters, and they want to know the range. Do not say the tangent of theta is equal to 40 over dx. That will not work, because this is an accelerated motion, this is not. So the tangent won't work. But what will work is I can say, well, 40 meters dy equals 1/2 gt squared plus vyit. Now, I don't have any idea what vyit is, but if I take it on the way down and talk about it falling, I can let that be 0, and my life is so much easier. Gravity is 9.8 t squared. So when I did that, I got t to be 2.86 seconds. So then I went back and said, okay, well, I know the time now, so Vyf equals Vyi plus gt. Vyf is 0 at the highest point. Vyi is what I don't know. Gravity is negative 9.8 because it's slowing it down. And t is 2.86 seconds. So I saw from my Vyi, and when I did that, I got my Vyi to be 28 meters per second. And then I said the tangent of 40 degrees is equal to 28 meters per second over Vx. So I solved for Vx, and I got Vx to be 33.37. But that's not what they asked me for. They asked me for the range. So dx equals bxt. So dx was 33.37. Now t has to be double because it has to go up and come down. So that's going to be 2 times 2.86 seconds. So when I did that, my range came out to be 190.87. And again, notice every number gets a unit.